This is from an aeroplane in the air and at a horizontal distance of 150 meters. The angle of depression of the top and the base of the control tower at an instance are 36 degrees and 41 degrees respectively. Calculate correctly the nearest meter, the height of the control tower. Now, the control tower is just a building at the airport, a very tall building at the airport, something like this, a very tall building at the airport from which the movements of air traffic are controlled, something like this. All right. So this says that from an aeroplane in the air and at a horizontal distance of 1050 meters, it means that the horizontal distance between the aeroplane and the control tower is 1050 meters. Imagine the aeroplane was just going horizontally like this. That means if we have the vertical distance between the aeroplane and the control tower to be this, all right, it means the horizontal distance will be this. This would be the horizontal distance. Let's just take the horizontal distance between the aeroplane and the control tower to be this. Okay, so the distance, the horizontal distance between the aeroplane and the control tower, let's take this as 1050 meters. This is 1050 meters. We're now told here that the angle of depression of the top and the base of a control tower at an instance are 36 degrees and 41 degrees. You know, the angle of depression is the angle formed when you look at an object just below you. This is the angle of depression of the top and the base of the control tower at 36 and 41 degrees respectively. So from the top, the angle of depression is 36 degrees. So this is the top of the control tower. Let's just fix it here. So the angle of depression is 36 degrees. I'll just take this as 36. Okay, so from that place to this place, this is the angle of depression, the horizontal distance down to this line here. This is 36 degrees. And this also says the angle of depression of the top and the base of the control tower. So this is the top of the control tower. Let's find the base of the control tower. So from here, we'll go down to the base of the control tower. Okay, this is the base of the control tower. So the angle of depression is 41 degrees. 41 degrees. From this horizontal line down to this one, this is 41 degrees. Okay, so from here I could just close this like this, closes like this. Now this angle here is 36 degrees and this one is 41 degrees. From alternate angle, you know, if you have something like this, if you have two parallel lines like this, two parallel lines, and you have something like this, okay, a straight line too like this, the angle, if you have an angle, if these are two parallel lines, the angle formed here is always equal to the angle formed here like this. So these are called alternate angles. So we'll apply the same rule here. If this angle is 41 degrees, this big angle is 41 degrees, it means this angle also will be 41 degrees. 41 degrees. Now if this angle is 36 degrees, this small angle here is 36, it also means that this angle here, the angle that will be formed here, will be 36 degrees. 36 degrees. Alright, now the question says calculate correctly the nearest meter, the height of the control tower. Now this is the control tower. It means that from here to here, from here down is the height of the control tower. This is the height of the control tower. Let's just put this as B, for example. Then the distance from the plane to the top of the control tower, let's just take it as this. Okay, let's take it as A, for example. And we have to calculate the height of the control tower. We can't just come here and start calculating the height of the control tower. We have to do something here. This is a right angle triangle. Let's say this is A, this is B, this is C, this is D, and this is E. Alright, so to calculate the height of the tower, what we'll do is we'll calculate the distance between the aeroplane and the base of the tower. That's the total distance here. Then we'll also calculate the distance between the airplane and the top of the tower. They will now subtract the two values. Then we'll get the height of the control tower. Okay, since we have two right triangles here, we can easily do that. Okay, this is also a right triangle, so we can just bring that out. ACD, let me bring that out. ACD, let's say this is the right triangle. ACD. Now the distance from A to C, let's just take it as H, for example. This is 41 degrees, this is 41 degrees, and this is 1050 meters. Alright, that's 1050 meters. We need to calculate h here. So to do that, we'll just use a SOHCAHTOA. SOHCAHTOA. This is the hypotenuse. AD is the hypotenuse. Which side is the opposite? The opposite is the side facing our angle. This is the side facing our angle, H. So we have H as the opposite. It definitely means CD will be the adjacent. So we have opposite side and the adjacent side. This is opposite side and the adjacent side. It means we'll use the tan. So say tan 41 degrees is equal to opposite, which is H, all over the adjacent, which is 1050. By the time we cross multiply, it will be H is equal to 1050 times tan 41 degrees. It means H, which is the distance between AC, is equal to 1050 times tan 41. Let's do that on our calculator. 1050 times tan 41. This is 912. Let's just say 913 approximately. This is 913 meters approximately. Okay, so it means that the distance between the airplane and the base of the tower is 913 meters. Let's just write that there. 913. This is 913 meters. That's the total distance, which is 913. We have the total distance now as 913. Let me just do this again. 913. Total distance as 913. Alright, so the next thing we need to find is the distance between the airplane and the top of the tower. Now why we are doing this is because we have a right angle triangle here. For the distance between the airplane and the base of the tower, we have a right angle triangle. For the distance between the airplane and the top of the tower, we have a right angle triangle ABE. So we can easily get the distance. But for the height of the control tower, we don't have a right angle triangle. Alright, so it's easier to find the distance between the plane and the base of the tower and the distance between the plane and the top of the tower. So let's find the distance between the plane and the top of the tower. So bring out the triangle ABE. Triangle ABE. This is ABE. This is A. B is a right angle triangle. Okay, this is 36 degrees. The angle here is 36 degrees. Okay, then we have this place as let's just say this is our A. We are looking for this distance A here, and the distance between B and E is still 1050 meters. 1050 meters. Okay, this is 1050 meters. We can also use the trigonometry ratio tan. Okay, since we have opposite and adjacent, just say tan 36 degrees is equal to the opposite, which is A, all over the adjacent. This is the adjacent, 1050 meters. So we'll just cross multiply again. We have A is equal to 1050 times tan 36 degrees, and we have A is equal to, this implies that A is equal to, let's calculate this, 1050 times tan 36 degrees. This is 762. Let's just 763 approximately. 763 meters approximately. So it means this distance A here, this distance is 763 meters. 763 meters. This distance equal to 763 meters. Now we can easily calculate B here. We know that 913 meters, that's the distance between the airplane and the base of the tower, is equal to A plus B. Okay, equal to A plus B. It means 913 meters is equal to A, which is 763 meters. 763 meters plus B, which is the distance between the top of the tower to the base of the tower, which is still the same as the height of the control tower. Okay, so just say B, which is the height of the control tower, is equal to 913 minus 763 meters, and this is equal to, just says 913 minus 763. This is 0. This is 8. This is 11 minus 6 will give us 5. 8 minus 7 will give us 1. This is 150 meters. 150 meters. So it means the height of the control tower. Can just say the height of the control tower is equal to 150 meters. Now the next question says, calculate the shortest distance between the aeroplane and the base of the control tower. This is the aeroplane here, this is the aeroplane here, and this is the base of the control tower. Now we can either go through this route, the hypotenuse AD. Okay, we can either go through this route to the base of the tower. Alright, this is a distance between the aeroplane and the base of the tower, that's AD. Or we can also go through this route AC and CD. Okay, we can either go through AD or AC and CD. But you agree with me that it's going to be a very long journey going through AC then CD. The shortest distance will definitely be AD, and we can prove it. Let's say since the distance AC is 913 meters and CD is 1050 meters, it means the distance ACD will be 913 plus 1050, and this is equal to 3. 1 plus 5 is 6, 0 plus 9 is 9, then we have 1. Okay, this will be total distance moving through the other route. But moving through the shortest distance is definitely going to be AD. Okay, to calculate AD, we can just use the Pythagoras rule since we have CD and we also have AC. Let me bring that out. Let me bring that triangle out. We have this, we have this triangle, we have this triangle A. Let me see the other side. This is ACD. ACD. This is where we are looking for. We are looking for this point here. Okay, let's just call it C, for example. Okay, we have this side as 913 meters and this side 1050. 913 meters, 1050 meters. You can easily find C using the Pythagoras rule. We'll just say the hypotenuse squared, which is C squared, equals the sum of the squared of the two opposite sides. That's 913 squared plus 1050 squared. And this will be C squared is equal to 913 squared is 913 squared is equal to 833569. 833569, this is 3 plus 1050 squared, 1050 squared, this is 1102500, 1102500. Okay, now this is C squared is equal to, let's add this to 833569. Let's see that 833569, 11025 plus 11025. Okay, this should be 5. 11025 then 00. After we sum this together, we have 193. This should be 193. Okay, 193 6069. 6069. Right, so we can just find the square root of both sides. We square root both sides. This cancel this. We have C equal to the square root of 193 6069. 19. Let's find the square root of answer. That's this. It will be 1391 approximately. So just write 1391 meters approximately. It means that the shortest distance between the aeroplane and the base of the control tower is 1391 meters. Wow, this question has really taken so much time, but well, we've actually solved it, and that's the most important thing. We've solved it.